After the second lesson, we move on to the sixth lesson because the third, fourth, and fifth lesson are not there for your end of term 3 exam. So we will move on to the module 12, lesson 6, that is proving angle relationships. We will look into the learning objectives of this lesson, that is to prove theorems about angles by using the angle addition postulate. We have to prove theorems about angles by using properties and theorems of angle congruence, and finally prove theorems about right angles. We will learn all of these in the coming videos. Now, a few of the key words which we'll come across this lessons are postulate, theorem, congruence, protractor, complementary, supplementary, adjacent. So these are few of the words. We will come across these one by one and we will learn them then and there. But few of the terms, I'm sure, like congruence, protractor, complementary, supplementary, adjacent, we have already come across them. Anyways, if you have forgotten, we will come across them in a while. And now about postulates. Now, postulates are similar to a theorem. It's like a statement. You do not need to prove them again and again. You can just remember these because they are always like a formula or a law. So now what does postulate, protractor postulate tell? The measure of any angle as a measure between 0 to 180, because a protractor is having 180 degree. And if it's a flat line, 180 degree means a line. Now the next one is angle addition postulate, which is very important. Now look at this figure, A, B, C, and there's a D in the interior. So D is the interior of ABC if and only if the measure of ABD plus the measure of angle DBC is equal to the total angle, that is the measure of ABC. So what it means is, if you add this over here and add this, you must get the total angle. That should be true. Otherwise, this is not an interior point. Few of the theorems we'll come across is supplement theorem, which we have already come across before. That is, if two angles form a linear pair that is 180 degree, then they are supplementary angles. So supplement means more, it's not 90. 90 is complement. Supplement is 180 degrees. So over here 120 plus 60 will make 180. That's a linear pair. Now complement theorem over here. If the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. If at all you get the sum of two angles as 90, it'll be complementary. Always remember, complement is something right. So right angle is 90. So it's 90 degree. It's up to you. You can remember anyhow, but I'll just tell it again. How I remember is, compliment is telling good about someone or telling them they are right about something. Right is 90 degrees, isn't it? Right angle is 90 degrees. So whenever compliment, think of right angle is 90 degree. Whereas in supplement, supplement is extra. More than extra or more than 90 is 180 degree. So that is the thing. And now we will look into a problem, angle addition postulate. Now we have over here measure of angle 3. If we need to find measure of angle 3, see over here in this figure, this angle. If the measure of angle 1 is 23 degrees and measure of the total angle is given, this total angle ABC is given as 131. Now how do we find angle 3? Looking carefully at the figure, you can see that this is given, measure of angle 1, but what about measure of angle 2? This is 90 degree, it's mentioned over here. So that is very important. It is 90 degree. And then we have the total angle 131. Now, you can use the angle addition postulate, which we saw. That means when you add all of these individual angles, you must get the total angle. That is, over here, measure of angle 1 plus measure of angle 2 plus measure of angle 3 must be the sum total angle. We have to just substitute everything. That is by substitution property. That means whatever the angles are, they substitute over here now. 1 is 23, 2 is 90, 3 is unknown, which we need to find, and the total measure of ABC is 131. Now what do we get? Take everything to the other sides and subtract, put it in the calculator, you will get 18 degrees. So this is the answer for this question. Very simple, very straightforward. All you need to know is whenever you have many angles, remember the sum, the total sum will be equal to the sum, sorry, the total angle will be the sum of all the individual angles. That's it. So this is the postulate. Now we have some check problems. I would kindly request you, highly encourage you to pause the video and try this by yourself, and then you can see the explanation for this problem. I hope you have tried pausing the video. So now let us see over here. They want to know the measure of angle 3, and they have told measure of angle 2 is 26. Now, same way like the previous one. Now here the measure of angle 1 is given in the figure. It's 90 degrees. 2 is 26. 3 is unknown. But the total angle is not given. But you can see there is a straight line. So if you remember the supplement theorem, we can apply that. Supplement theorem says whenever there is a linear pair, when you add these, you should get a straight line, isn't it? Linear. So that means the total sum will be 180 degree. So just substitute it now. It will be 90 in the first, 26 for the second, third is unknown, and 180. So all you do is substitute over here, and then over here it will be measure of angle 3. Take everything to the other side, keep measure of angle 3 at one side, and then now you can get that as 64 degrees. So this is how we solve it. Very simple, very straightforward. We'll quickly see this as well. The second check problem. Over here, again, it's the same thing. You can see in the figure, it's a straight line. So the sum of this must be supplementary. That is 180 degrees. But this is a little bit unique because they have given this measure of angle 4 in terms of, sorry, measure of angle 4. Yes, we need to find the measure of angle 4, but they have not given us a value. They have given us variable. So x plus 9, and over here it is 2x. So all you need to know is this is the measure of angle 4, that is x plus 9, phi is 2x, and now substitute these x values over here. Instead of 4, it will be x plus 9, instead of phi it is 2x, and remember it's a straight line, so the sum must be 180 degree or a linear pair. So that's why from supplement theorem we can write this as 180 degrees. Now you can simplify this. It'll be 3x equals 171, and take 3 to the other side. You're getting 57 degrees. Remember, this is not your final answer. This 57 degrees is just the angle x value. That's it. Now, how do you find measure of angle 4? Put this x value back in the given x plus 9, and then find the measure of angle 4. Sometimes what happens is you will start solving, you will get the value of x, and you think that's the final answer. No, this is not. You need to substitute in the given equation, that is measure of angle 4 equals x plus 9. Whatever you just now found was just x because you substituted both the values of x, right? Now x is found out, put it back over here. 57 plus 9. Now measure of 4 equals 66 degrees. So this is your final answer. We will solve more problems on complement and supplement theorem. Here we have got a problem where Fatima is installing shelves in a room. One of those brackets she chose for her shelves is shown. This is a bracket which she for a shelf, and you can see the angles are given. The measure of angle 3 over here is 55. This one is 55. And what is measure of angle 4? So now what is this measure of angle 4? That is unknown. Now over here they have given this angle 90 and all that, but that is all not required. What is required is only finding this angle over here, measure of angle 4. And you know the total angle will be 180 degrees. Why? Because it's a supplement theorem, linear pair. So now, given is measure of angle 3. Angle addition postulate says that measure of angle 3 and 4 based on supplement theorem would give us 180 degrees. So now just substitute the angle 3 and over here we know it's 180. Find the measure of angle 4. Take it to the other side. Solve. It's very simple. Just like the previous solving. Previous video we had solved similar problems. Now over here I would request you to pause the video, try it by yourself, and then you can see the explanation for this problem. I hope you tried pausing the video. Now then, we will check this. A city planner is designing an entrance ramp for a freeway. In the diagram, measure of ACD is 45 degrees. What is the measure of BCA? BCA. Now you can see again, this is a supplement theorem problem. Here it is 180 degree in total. We know 45. What is the remaining angle? Same way, we will write it in details. Measure of ACD is given to be 45 degrees. Now use the supplement theorem and we know the sum of both of these angles. It will be BCA plus ACD will give us 180 degrees. So now over here, BCA is what we have to find. ACD is 45 equals to 180. Take 45 to the other side, solve. This is the answer. Now, in case there was a complement, it would be something like this. They would give you one angle and then you need to add them both and it will be equal to, when you add two angles of complement, it will be equal to 90 degrees. So it depends on the question. Now there were supplement problems. They're very straightforward, just like how we have solved. That's it. Now we will learn about congruent angles. Before we start with the problems, we will go through few of the theorems. Over here, we have few properties of angle of congruency. So this is measure of angle 1, 2, and 3. These are three separate angles. The reflexive property of congruence says if you have this angle, this is equal to itself. So this is not a big deal. If it's 30 degrees, 30 is equal to 30. That's what it means. This is equal to itself or congruent to itself. Now, symmetric property of congruence says if you have this and this equal, say 1 and 2 are equal, then you can also write 2 and 1 is equal. You can write the other way around. 2 and 1 is also equal. And the last one, transitive, which is very important. Generally, this is a crucial one. So it says if 1 and 2 are equal, and then let me change the color, 2 and 3 are also equal. Then what does it say about the rest? This says 1 and 2 are equal, 2 and 3 are equal. This says that 1 and 3 must be equal, because if this and this is equal, so whatever this is, say 20 degrees. Now this is also 20 degrees. And this is equal, so this also will be 20 degrees, so these must be equal. This is the transitive property. Now the congruent angles for congruent supplements theorem, this is important. Now imagine you have these three angles and the measure of angle 1 plus 2 gives you 180 degree. And you also know that measure of angle 2 and 3 gives you 180 degree. Then this first angle and the third angle will always be equal or congruent. So now imagine this is 40 and this is the remaining angle of 140. Okay, so it's 180. Okay, this is not true to the figure because angle 1 must be bigger. Okay, let me change it and let me make it. This looks around 120 and this looks around 60 degrees. Now it's more accurate. So now this adds up to 180 and they have told 2 and 3 also will make 180. So now 180 minus 60 will give you 120, isn't it? So this has to be equal with 1 because over here 1 and 2, these will not be the same. It can be same, but you can see that how do we find 3? It will be 180 minus 60, so whatever, these both will be the same thing. So this is the thing. about angles supplementary to the same angle or congruent angles are congruent. This is what it means. Um, Now, these are abbreviation. Instead of reading all this, you can see this angle symbol and S means supplementary to same, or this is, you can just read it like angles congruent supplement to same are congruent. That is what it means. Now, you can see this much is all this. It's just the short form, but anyways, if you understand what it means is more than enough. This is fine. Now over here, same thing, whatever we just now learned can be implemented to complements as well. So now if you have this measure of 4 and 5 to be 90 degree, when you add them, see, it's given. So now let's say this is 30 and this is 60. Now they have also told 5 and 6 is also 90 degrees. So if this is 60, what is this? It has to be equal to 4, that is 30. So 4 and 6 will be equal, same like the previous one. Now it says angles complementary to the same angle or to congruent angles are congruent. So this is the thing. And now the last one, vertical angles theorem. Now we have come across this before already. Now remember, to have vertical angles, these must be straight lines. If they are not straight, if they are something like this, no, you can't have vertical angles then. This is not vertical. It must be straight lines. 1, 2, 3, 4 angles are known. So whichever are opposite to each other, 1 and 3 over here and 2 and 4 are congruent. So remember, opposite to each other. And over here, in this case, 2 and 4 as well. So that is about vertical angles. Sorry, if two angles are vertical angles, then they are congruent. Okay. Now let us solve a couple of problems. Over here we have a figure given to us. Angle ABE and DBC are right angles. We need to prove that ABD and EBC are congruent. Now remember, they have asked us to prove. We need to make this generally will be a writing question. So now what we have to do is, first we'll just analyze the figure, understand what is given to us, and then proof is always by making two columns. So let's make a column over here with statement and the reasoning behind it. Let's write the first statement, whatever is given to us. What is given? ABE and DBC are right angles. That is even in the figure, ABE and DBC. Okay, that's given. What about the next thing? If they are right angles, that means measure of ABC is equal to 90 degree and measure of DBC is also 90 degree. That is the definition of right angles. Then we can see over here, look carefully at the first one. Then ABD and DBE will be what? It will be complementary, isn't it? So this and this will be complementary. And it's not over. We have one more, that is DBC. So DBE and EBC will be complementary. Now you can realize we have this DB overlapping. So if this is 1, 2, then this is 2, 3. These 1 and 3 must be equal, isn't it? So congruent complements theorem stated that just a while ago we saw that. You can pause and rewind the video. It stated that what? This and this will be equal. So from congruence, this is from complement theorem, but from congruent complements theorem, we can state ABD and EBC are congruent. So this is the proof. First was given, then what is given? It's about 90 degrees. So we are just writing the definition of right angles, and then we are telling about complement theorem. That means if we know this is 90 degree, then whatever angles are in between them will be complementary. And then from congruent complements theorem, we can say if at all the same angle is overlapping, then the remaining other two angles will be congruent. This sign is congruency. So that means ABD and EBC are the same. Similarly, try this vertical angles problem. It is also to prove, so therefore you must make a table and two columns, statement and reason. I would highly encourage you all to pause the video and try this. I hope you have at least tried a little bit. Now at least the given and few lines, you can have tried. Now let's see that. First thing, we have to analyze whatever is given. So we have to prove 3 and 4. We know 1 and 2 is equal. Now, make the two columns, statement and reason. Over here, the first one, angle 1 is congruent to angle 2. That is given. What are the next things? We know 1 and 3. See, 3 and 4, it's what we have to prove. That we'll prove in a while. But because these are vertical angles, we know 1 and 3 and 2 and 4 are congruent. That is from vertical angles theorem. Okay, so what next? 3 and 1 are congruent because vertical angle, right? And now this is what we have written as symmetrical, because over here 1 and 3 was written. Now we just swap them. 3 and 1, this is symmetrical property. Okay, now look over here. We are just writing this 1 is congruent to 2, right? So we will write this by transitive property. Now what it means is, see, 1 is congruent to 2, 3 is congruent to 2, 1. So that means these both must be congruent, 3 and 2. Or else you can also think of this as replacing. Instead of 1, I'll write 2 over here. Okay, because they're congruent. Congruency means same. So now we have got congruent, angle 3 congruent to 2. Now look at this again, vertical angles theorem. We already stated 2 is congruent to 4. So 3 will be congruent. Instead of 2, write 4. Again, we are using the transitive property. So the only thing is, write the vertical angles, then it is just symmetrical or transitive property. Sorry. It is either, after writing the vertical angles, it is either symmetry or transitive. So this is the way we can prove the angles. So remember, whenever it is a proving problem, please make this two columns and then write. First start with the given and then look at the figure and analyze which is the property that is most suitable. Over here, it's not about complement. Over here, it's about vertical angles. So use vertical angles, and then from symmetry and transitive, we can easily prove this. The final objective of this lesson is to prove theorems about right angles. Now we will go through few of the theorems about right angles. That is, looking at this figure, you can see all the angles are equal, that is 90 degree. The theorem is that if perpendicular lines intersect, they form four right angles. It is obvious because wherever two perpendicular lines exist, there is a right angle formed. So if a line is perpendicular to another line, it's right angles that denotes it. So when two lines are perpendicular, all the angles will be right angle. Now another theorem is about all congruency, that all right angles are congruent. It doesn't matter how they are. If this is a right angle and this shape, doesn't matter how it is, it's not the same shape, but if there is right angle, then they are always congruent. So all these, whether it's a small shape or a big shape, if it's 90 degree, the angles are always congruent. And then we have perpendicular lines form congruent adjacent angles. Now over here, whenever there is perpendicular lines, we know it's always right angles, right? So if there is one right angle formed, even the other side will be right angle. That means the adjacent angles, the angles which are next to them, are congruent. So adjacent angles are the angles which are next to each other. And they are congruent. Why? Because perpendicular lines form 90 degree everywhere and the adjacent angles are congruent. And then we have, if two angles are congruent and supplementary, then each angle is a right angle. Now this is about supplementary. Now supplementary means it's total 180 degree. Now if the angles are supposed to be supplementary, the sum of the two angles must be 180. But they have also mentioned if they are congruent and supplementary. If two angles are equal and supplementary, that means they must be same, divided by 2. Both are the same thing. That means both of the angles must be right angles. So this is another theorem. And then we have, if two congruent angles form a linear pair, then they are right angles. Again, it's similar to the previous theorem, because if they are linear pair or supplementary, that means the sum of two angles must be 180 degree. And if two congruent angles form in a linear pair, that means the angles must be equal and the sum must be 180 degree. That means it must be 90 degree itself. So it is 180 divided by 2, so it is 90. And now we will come to a few of the problems over here. We have to use the right angle theorem and prove it. Now they have asked us over here in the figure 1, angle 1 and angle 4 are congruent. Prove 1 and 2 are right angles. In the previous problem, in the previous videos, you might have seen a similar problem where we had been given two adjacent angles to be congruent and then another angles must be equal as well. But now it's not that case. They're asking us to prove that they're right angles. It is one step further to the previous problem. Let us start solving it. First, we need to analyze the given statements and understand the figure. And then we have to make the two column proofs, statement and reason. Now the first given, that is angle 1 is congruent to angle 4, that is given. Now over here 2 and 4 are vertical angles, so we can use vertical angles theorem and tell that 2 and 4 are equal. So then 4 and 2 are also equal. Why? Because it is symmetrical property. Reflexive means only one, symmetrical means two, transitive means three. Okay, so symmetry means you're just writing them each other, swapping them. If 2 is equal to 4, then 4 must be equal to 2 in over here the angles I mean. And then we have transitive property, which tells if 1 is equal to 4 and 4 is equal to 2, so we can write over here 1 is equal to 2, because you can see over here in these two lines, these and this are equal, isn't it? So we can just equate these both as well. And now then, lastly, if we know 1 is congruent to 2 over here, these both are right angles. Why? Because they're supplementary, right? Over here you can see it's a straight line, it's supplementary. If two angles are congruent and supplementary, each of them must be a right angle. That is a right angle theorem which we just came across in this video. So this is what this is how we can prove them to be right angles. Basically prove them they are equal like we have done in the previous video, using all these property, vertical angle, symmetry and transitive property. Then you can tell that they are right angles because they're supplementary and they're equal, so they must be right angles. So this is it in this lesson. It's about proving. So main thing what you must remember about proving is first write the given and then write the important equations from the figure, and then see what you need to do. Because when you write everything that is given, and then now for example over here, when you write everything that is given and then see over here which property to use based on the figure, okay, this is about vertical angles, and then you can easily come to what you want. So this is the thing. Practice more problems and then it'll be very easy. And if you have any questions, please put them in the comments and I'll get back to you as soon as possible.